Alright, in today's short video, we're going to talk about how to write formulas of ionic compounds. The first method we're going to use is the crisscross method. This is very useful when you have monatomic ions. So here we have aluminum 3 plus and an oxygen 2 minus. The crisscross method, you take the cation charge and that becomes the anion subscript. You take the anion charge and that becomes the cation subscript. So we end up with Al2O3. Now, key thing is we don't keep those charges. They do not show up in our formula. So no charges in the formula. So let's do another example. In this example, we have magnesium 2 plus and the chloride 1 minus. So remember, the cation charge becomes the anion subscript, and the anion charge becomes the cation subscript. So that gives us MgCl2. Alright, the second method we're going to use is the electroneutrality method. This is making sure that we don't have any excess positive or negative charge in our formulas. Really, what it comes down to is we're looking for the least common multiple of 2 and 3 in this case. Aluminum with a 3 plus, oxygen with a 2 minus. That least common multiple is going to be our smallest amount of charge that we can have inside our formula. So the questions we need to ask ourselves are, what times 3 equals 2? In other words, what subscript do I have to put in with the aluminum in order to make 6? And what subscript do I have to put into the oxygen times 2, the charge on that oxygen, to make 6? Obviously, we can see that 2 times 3 is 6 and 3 times 2 is 6. And look, we get the same answer we did when we did the crisscross method. Both ways are equally valid. So which method should we use when writing our formulas? The crisscross or electroneutrality? The thing is it really doesn't matter. Electroneutrality I tend to use because it reminds me that we have the law of parity. For every plus there's got to be a minus. But the crisscross method works as well. The only hang up with the crisscross method is when we start dealing with polyatomic ions. So for example, when we have the ammonium ion and the carbonate ion, if we use the crisscross method, we'll put the plus down there, and it's plus 1, so we don't have to do anything, but we put the 2 down there. Now, you might be tempted to write this as NH42CO3, and that says that we've got 42 hydrogens. That's not right. So when we do our polyatomics, to separate those out, we need to make sure we use parentheses so that we see the NH4 as being a separate unit, and then we have 2 of those for the carbonate, so that the unit of positive charge, the 2 ammonium ions, are added to the 1 carbonate ion because it has a negative 2 charge. So you need 2 positive ones for the negative 2. So, in conclusion, ionic formulas are always empirical formulas. That means they're always going to be in the simplest whole number ratio. So if you determine from whatever method, crisscross or electroneutrality, that you need 2 of each of the ions, that is not the simplest whole number ratio. Bring it down to the simplest whole number ratio. In other words, 1 to 1. Do not leave the charges in your formulas. That is not a good thing to do. You will never ever see charges left in any formula. And never use a subscript of 1. Just the fact that you have the element symbol there means that there's already 1 there. And make sure that you use parentheses to separate out polyatomic ions to show that they are separate units of charge. You only have to put parentheses around polyatomic ions if you have multiple polyatomic ions. You never have to put parentheses around any monatomic ion.